And we are live in theory. Hello everyone, and welcome to Learn Solus Packaging, session 4-2. This is an extra or supplementary session to session 4-1 and session 4, which is the beginner session. It just covers a few topics that aren't typically covered in those sessions. Things you may use less, such as using a local repository, disabling automatic library splitting, and I need to mute my video. There we go. And building emo32 or 32-bit libraries, as well as doing package renames or replaces. So let's go ahead and get started with that. So let's start off, because this is really simple, with packaging using a local repository. Now, why might you need to do this? Well, let's say you have a complex dependency chain. So you're working on a package and there's 5 other packages that you also have to build before you work on your primary package, as an example. Or say you're working on a bit of a Haskell package or a bit of a Perl package, but it turns out there's 5 other Perl packages you need to package first, and none of those are in the repository. Now, what you could do is submit those one by one and have them trickle into the repository, or what you could do is set up a local repo, copy all those EO packages you generate over to your local repository, and then just run make local and build based off of those local packages. So in order to do that, we need to install our local profile, which is based on unstable. And we actually provide a command here. If you go over to our help center and then go over to packaging, and then packaging using a local repository. And we have this install command here. So let's go ahead and copy that into a terminal. And let's go ahead and run that. And wow, who would have thought I already have it installed? So let's go ahead and check out what that package is. And as you can see, it contains a single file, which is a .profile, just an ini file, in user share sol build directory. So let's go ahead and open that up. So as you can see here, it uses the unstable image. It removes a Solus repository and adds the local and then Solus. So basically what it does is it makes sure that we check the local repository first. It then specifies the path to where we are going to be storing our EO packages, which is var lib sol build local. It's set to local, and then it does auto index of true. So whenever you start a build, it automatically indexes whatever is in whatever exists in that repository. And as you can see here, if you do ls var lib sol build local, you'll have your typical EO package index, SHA-1 sum, XZ, and XZ SHA-1 sum. And this is actually quite similar to the repository that you would typically have if you're just using the unstable repo or using the main stable repository. So the difference between using a main repository, using the unstable repository, and using a local one is if you go into a package, rather than running make, so say we're in a package repository here, or we could see about this later when we're building a package, and we type make to start compiling, rather than that, what we would do is run make local, and that would instead use our local repository. Now, it is important to note that regardless of if there's a higher release of a package, we will always prefer to use a EO package in your local repository. So it is important to note that if you are going to be using a local repository regularly, that if you have anything in there that might be old or stale, that you clear it out every once in a while. So that's really it. So let's go ahead and move on to library splitting. So we go to my docs. So library splitting is pretty common for our devel packages. So we will automatically split off shared object files. But it may be necessary to disable library splitting and have those shared object files in your main package if the expectation is that the binary in there is linked against the shared object, or if there's another expectation, say in our IRL example here, which is plotness, that we need to use that shared object file, say if we are exporting a variable, if we are using it as a GDK module, and so on. So in our example, we are going to be using plotness, which is a searchable command palette for GDK3 applications. So let's go ahead and jump on over to pu/plotness, go over to the releases page, copy the link, let me go up and fire up G out there. And let's go ahead and just fill in some of the details here. It is GTK3, and I know it's GTK3 because if you scroll all the way down, you see under license it says released under the terms of the GNU GPL, well, the GNU General Public License version 3. So what does it need to compile? It needs GTK3 and it needs Vala. You see here it also requires Git on occasion if you're building it from the Git repo. And it needs CMake, which is part of our system.devel, so we don't actually need to use that. So let's go ahead and get the package config for GK3. And let's just use GTK plus -3.0. And it also needs Vala, so let's just go ahead and add that in there. Now, because it's just a basic GNOME application, we're going to set the component to desktop.gnome. And let's go ahead and add that summary and description. And let's go ahead and just run make as it is. And as you can see here, it's specifying to use the unstable repository because we ran make as opposed to make local. So it's going to go ahead and fetch a bunch of packages that are already local and cached. And while it's doing that, let's go ahead and open up Fabricator. Let's search for plotness because we are going to need a file in here later. So while it's compiling in the background, we're going to go over to the files section here. And we are going to click on the 70-plotness.sh. And we are going to then click view raw file and make a files directory in the same directory as plotness, well, in the directory of plotness, and save this file to there. Now if we go back, you can see our build is complete. If we run ls, it created the ABI symbols, ABI used files. I already did the files bit of downloading and downloading this. But as you can see here, it generated a plotness EO package and a plotness devel EO package. And if we load up, if we do an LSEO package of plotness 020, you can see here we have just a glib schema, or glib schema. And if we do an LSEO package on plotness devel, you can see we have user libplotness.so. Now, it is important to do a library split, to disable the library splitting for this package, because if you look at our 70.plotness.sh, you can see we export GTK modules and reference, so either we export it or we append a reference to the absolute path of user libplotness.so. And the reason why that is, if we go down here, it does some funny business to GTK application. And for that, we need to actually have it as a GTK module, so it's actually available when we launch a GTK3 application. Now, having that file stored in your files is great and all, but you actually need to install it. So I'm going to copy a couple commands here. So in essence, what we're doing is we are installing from our files directory the 70.plotness to the user share defaults, etc profile d, and then 70-plotness. So we actually are doing two install commands. The first one is creating all those directories because it has a different permission, and then we are installing it. So if we were to run make again, let's do that. Let's switch over to this tab. And we are to do an LSEO package on the plotness 0.2.0 EO package again. You can see we now have this user share defaults etc profile d70-plotness. Now, what does this mean? It means that there is the expectation that when the user is installing plotness, that is just going to work out of the box, because we are setting in this profile d file the GTK module. So every single time that we start a GTK3 module, it'll search then for, well, every single time we start a GTK3 application, it will then search for this module. So we need to do a disable of library splitting, and that can be done using libsplit set to no. And what that'll do is it'll move all of our shared object files over to our main package. Or I should say, it just simply won't move them to the devel to begin with. So let's go ahead and do that under component. And let's run make again. I'm going to run make clean, so we're deleting both of the EO packages. And if we do an ls, you can see because we only had that single shared object file in plotness devel, now that we have used libsplit, that devel package, that devel subpackage does not exist anymore. And if we run LSEO package on plotness, the EO package for that again, you can see we have that libplotness.so in that main file, in that main package now. So what that means is when we install plotness, it'll work out of the box. Our script here for appending the reference to libplotness.so will work. And that means when you launch a GTK3 application, everything should be all hunky-dory. If I could remember what the... I'm not actually... So Control-Shift-P. I don't think I actually have it set up here. Fail. But it will be a default in upcoming. Well, actually, it should work. Whatever. So, moving on from that disaster. Let's go ahead and do 32-bit enabling. Now, building 32-bit packages is pretty common if you are using Wine or Steam and want to use our native runtime, or you want your Wine package to, say, play OGG, or have the ability to compile against OGG. So we are going to use OGG as an example here by going to vorbis.com. We are going to obtain the source code by going to their download page beneath their banner there. And we are going to right click on the libogg132 tarball here. We are going to generate the YAML for it. We are going to set the component as multimedia.codecs. Now this is a BSD3 clause for the license. And I know that because prior to this stream I had actually downloaded the tarball and I opened it up and looked at the copying file. So we are going to just copy paste OGG format library. It does not have any build deps, so we can remove that. We are going to disable the building of static libraries. And we are going to do something a bit different. And that is we are going to intentionally mess up on the name of our package. So we are going to change it to libogg ASDF. And you will understand why when we get back to the renames section of this session. So fortunately, that does not take long at all to compile. And if you can see here, we have our libogg ASDF and our libogg ASDF-devel. That's great, except we want to build 32-bit libraries for this as well, so it could be used with Wine and Steam. And for that, we are going to go over to our package.yaml over at the Help Center. We are going to scroll down to optional supported keys. And as you can see here, we have this emul32. And what we do is we set it to yes. So let's go ahead and do that. And let's run make again. So what it's going to end up doing is two completely different builds. It's first going to do a build for 32-bit, and then it will do a build for our normal x86 64-bit. And if we do an ls here, you can see we have libogg ASDF, and we have libogg ASDF-32-bit, as well as the 32-bit -devel and the normal -devel. And if we do an LSEO package on the 32-bit subpackage, you can see we actually store those in user lib32. And we also then have the LSEO package libogg ASDF 32-bit-devel, which has the shared object file and the package config in there. If we do an EO package info, you can see we then have a different package config. So our package config here is called package config 32 as opposed to normal package config. And what that means is we can then use it with, say, Wine and reference the package config 32 so we could build the Wine-32-bit support. Well, 32, but yeah, 32-bit support. So let's say we done goofed during review. Somehow this slipped past. somehow our package is called libog.asdf and as opposed to just libog, and we want to change that. So this actually requires a bit of manual intervention by typically IT on the team. So what we need to do is we need to do a replaces. So we are replacing one package that may already be on the user's system with another one. So that's a seamless upgrade. So say you're upgrading from the software center or you're upgrading via sudo eo package up. It will replace libog.asdf with libog, which is what we will do. So we are going to do a make bump. Reload this over here. You can see it changed our release from 1 to 2. And we are going to do a rename here. So you would think, oh, it's automatically named libog now. I don't have to worry about anything. Not true. We are going to go over to our packaging practices. And we are going to go to the replace/rename. And we have a replaces list bit here. So basically we are going to replace, say, the devel, our devel subpackage, and we are going to specify what it's going to be replacing. And we are going to be doing the main package and then what it's going to be replacing, and we're going to be doing that for 32-bit as well. So I already have this prepared. So let's run through this. So we have a replaces section here. It was previously named libog.asdf. So what we're saying is our main package is going to replace libog.asdf. Our devel subpackage is going to replace libog.asdf-devel. Our 32-bit is going to replace the 32-bit equivalent, and the 32-bit-devel is going to replace the 32-bit-devel equivalent for libog.asdf. Now, this won't actually affect anything that is compiling against this in a normal scenario because we are using the package config in applications such as Wine. So we don't actually have to worry about that, about updating other packages. So what we are going to do is we're just going to run make again. Now it's worth noting that if we do an ls, so if we do an eo package info, so we now have that libog and we had that libog.asdf. Ignore the ASDF ones because I just forgot to run make clean. Those wouldn't be generated. Only the libog ones would be. But if we do an ls eo package, sorry, once again, eo package info, as you can see, we don't specify the bits here as in terms of we don't specify the replaces section. But if we look at the pspec file that's generated, you can see we have these replaces sections here. And in these replaces sections, we specify that, say, for instance, with this libog 32-bit devel, that it's going to replace this libog asdf-32-bit-devel. So after you do this and you upload your patch, what you need to do is coordinate with Ike. So you need to reach out to him via IRC typically. And you need to say something along the lines of, we need to replace package X with package Y. Can you please deprecate the package from, say, the repository? So that way, on the repository side, because that's a bit more of a manual process, we ensure that the replaces will actually happen and the libog.asdf is marked as obsolete. And that's that. That's how you do a package rename or a package replace. And that's it for the session. So thank you for joining me. and I will see you on the next one. Bye bye.